Hello, my name is Kurk Mathews. I'm a Senior Applications Engineer at Linear Technology. Today I'm going to talk about the LTC 3765, LTC 3766 synchronous forward converter chipset for use in high-efficiency isolated DC-to-DC converters and battery chargers. We'll learn how this product makes it easier to design a high-performance and reliable forward converter for power levels ranging from 25 watts to over 1 kilowatt. A forward converter is very similar to a buck converter. Each has an output inductor, capacitor, and synchronous switch. The top switch in a buck converter is replaced by the forward converter's primary and forward switches. Diodes could be used in place of the forward and synchronous switches, but switches make it more efficient. On the forward converter, a transformer provides isolation between grounds and allows the output voltage to be less than or greater than the input voltage. The transformer turns ratio is adjusted to optimize the duty cycle. For example, when stepping down from 100 to 1 volt with a buck converter, the duty cycle would be 1%, whereas a forward could operate at 20% or higher. Again, this means higher efficiency. Every transformer must have balanced positive and negative voltage applied to it. If a transformer were ideal, this wouldn't matter, but a real transformer can be thought of as an ideal transformer with an additional magnetizing inductance across the primary. When voltage is applied to the transformer, the current in the magnetizing inductance will either ramp up or ramp down. Any imbalance in the transformer voltage will cause the magnetizing current to walk up or down towards saturation. A saturated transformer behaves like a short circuit, which can cause the power supply to fail. Active clamp reset uses an additional capacitor and switch to apply a reset voltage during the converter's off time, keeping the magnetizing current centered around 0. Now let's go into the lab and see an active clamp forward in action. This is an 18 to 72 volt input to 12 volt, 12.5 amp output demo board, powered from a bench supply. The upper trace is the transformer magnetizing current, and the lower trace is the primary drain voltage. As I vary the input voltage, the duty cycle and reset voltage change, but the magnetizing current remains nicely centered around 0. Next, I will use a MOSFET and pulse generator to apply a 0 to 10 amp load step to the 12 volt output. The magnetizing current temporarily increases, then decreases to adjust the reset capacitor's voltage. Active clamp reset has some important advantages and challenges. The reset capacitor applies the lowest possible reset voltage, allowing the use of lower voltage MOSFETs, which maximizes the efficiency. However, the voltage on the reset capacitor must change with duty cycle, and if the duty cycle changes too quickly, the capacitor's voltage may not be able to keep up, resulting in saturation. Until now, this basic issue has only been indirectly addressed with band-aids such as slow feedback loop and duty cycle limits. Unfortunately, these fixes degrade performance and don't really guarantee the transformer won't saturate. The LTC 3765, LTC 3766 chipset features direct flux limit, which actually prevents transformer saturation. Direct flux limit works by directly sensing and limiting the magnetizing current in both directions. This example shows the load and magnetizing current during a load step. Without direct flux limit, saturation occurs, but direct flux limit keeps the magnetizing current under control. Unlike conventional fixes, direct flux limit only limits the magnetizing current when absolutely necessary, resulting in a transient response that's up to 10 times faster. This product has other remarkable features that make it great for charging a battery, including clean startup into a pre-biased output, a fast, accurate average current limit, polyphase capability for higher power, and secondary side control, which uses a tiny pulse transformer to close the feedback loop instead of a less reliable opto-isolator. Today, many systems require isolated supplies that are both reliable and efficient. The LTC3765, LTC3766 forward converter chipset meets these challenges with a new level of simplicity. Visit us at linear.com for more information. Thank you.